Imagine standing in East Africa, roughly 200,000 years ago. You aren't a monarch, a farmer, or a celebrated scholar. Just a typical early Homo sapiens, scanning the horizon, wondering where your next meal will come from, while desperately hoping a predator with larger teeth doesn't spot you first. If you could somehow capture a portrait of yourself and compare it against the 8 billion individuals inhabiting the planet today, one physical feature would immediately jump out. You almost certainly wouldn't possess pale skin, East Asian facial traits, or red hair that suffers under the summer sun. In fact, early modern humans almost universally possess dark pigmentation. This biological reality introduces a fascinating evolutionary question. If our species originated with dark complexions, how did the immense spectrum of human skin tones emerge? Today, human skin ranges from deep obsidian shades to extremely pale tones, with virtually every conceivable shade in between. Certain populations adapted lighter complexions, others retained deep pigmentation, and some developed completely unique genetic solutions to solve identical environmental challenges. The story behind this transformation represents one of the most compelling examples of visible natural selection in action. To understand this journey, we must return to the initial human template. Here is a factual reality that many people overlook. For the vast majority of human existence, categories like black, white, or Asian simply did not exist. Those social classifications are remarkably recent inventions. For nearly 90% of Homo sapiens history, our entire species resided exclusively within Africa. Africa receives an extraordinary volume of solar radiation, the kind of intense sunlight that feels pleasant on a weekend getaway but can quietly disrupt cellular DNA when experienced continuously over thousands of generations. This is precisely why human biology relies on melanin. Melanin is the organic pigment responsible for darker skin tones, acting effectively as biological sunscreen. It absorbs destructive ultraviolet UV rays before they can mutate cellular structures, degrade vital nutrients like folate, or trigger severe physiological complications that natural selection generally disfavors. In equatorial regions, where solar radiation ranks among the strongest on Earth, possessing high melanin concentrations was not merely advantageous, it was vital for long-term survival. Generation after generation, individuals with heavier skin pigmentation were better equipped to withstand their hostile, sun-drenched environment. Over immense spans of time, dark skin established itself as the species' baseline. Evolution didn't operate out of aesthetic preference. Natural selection remains entirely unconcerned with appearance. It evaluates a single metric. Did an organism survive long enough to pass on its genetic material? For hundreds of millennia, heavy melanin production stood as one of humanity's most effective biological defenses. Then, human populations began to migrate, and the evolutionary story took a fascinating turn. Between 60,000 and 80,000 years ago, bands of early humans began venturing beyond the African continent. Some groups traversed the Middle East, others expanded across the European landmass, and additional populations pushed eastward into Asia. Eventually, human settlements reached Australia, the Siberian tundra, and ultimately crossed frozen land bridges into the Americas. This feat becomes even more impressive when you consider that these early travelers possessed no navigational charts, compasses, or modern positioning devices recalculating directions every 10 seconds. They simply kept moving forward across generations. As populations migrated farther from the equator, environmental conditions shifted dramatically. Solar radiation weakened significantly. At first glance, reduced UV exposure sounds entirely positive. Less risk of cellular damage and fewer sun-related health complications. However, a major biological obstacle emerged. The same ultraviolet rays capable of harming human tissue are also required for the body to synthesize vitamin D, a crucial compound responsible for bone density, immune system function, and healthy physiological development. While an individual can technically survive with depleted vitamin D levels, evolution does not reward mere survival. It rewards reproductive success and biological vitality. Suddenly, the dense melanin protection that served humans so brilliantly in equatorial Africa created a distinct disadvantage in northern latitudes. Heavy skin pigmentation blocked ultraviolet rays with supreme efficiency. But in regions receiving minimal sunlight, that protection came at a steep physiological cost. Northern populations required greater sunlight absorption. Over vast spans of time, natural selection began favoring individuals who possessed lighter complexions. This shift did not occur overnight or across a few generations. It unfolded across thousands of years of gradual genetic adaptation. Recent scientific breakthroughs have revealed a surprisingly unexpected detail regarding European prehistory. The earliest human settlers of the continent maintained dark complexions for thousands of years. Modern European features did not magically materialize the moment early humans set foot in the region. Advances in ancient DNA extraction have completely restructured our understanding of human migration. Genetic analysis reveals that many hunter-gatherer populations living in Western Europe thousands of years ago possessed dark skin paired with striking light blue eyes, a combination that looks as though evolution randomized character traits during a creation screen. Nevertheless, that is precisely what the fossil record demonstrates. The pale pigmentation commonly associated with European populations today became widespread much later, driven by the expansion of agriculture, shifts in dietary nutrients, population mixing, and the rising frequency of specific genetic mutations. Lighter complexions eventually dominated northern European regions because they maximized vitamin D synthesis under low-light conditions. Pale skin did not evolve because it was inherently superior. It simply offered a functional solution to specific environmental pressures. That is natural selection in its purest form. No master architectural design, merely ongoing adaptation. Here is where the genetic narrative becomes even more interesting. Asian populations solved the low-light challenge using an entirely different biological mechanism. Imagine two students completing the same complex mathematics exam. Both arrive at the correct final answer, yet each employs completely different formulas to reach it. That scenario mirrors the evolutionary trajectories of European and East Asian populations. While both groups independently developed lighter complexions relative to their common African ancestors, the underlying genetic mutations responsible for these transformations are distinctly different. They achieved comparable physical adaptations via separate evolutionary pathways. This discovery demonstrates that natural selection did not follow a single predetermined blueprint. Distinct human groups encountered identical environmental hurdles and independently evolved custom biological solutions. The final adaptation was similar, but the genetic road taken was fundamentally distinct. Popular cultural discussions frequently reduce human skin color to a few neat, distinct categories: black, white, Asian. While simple to conceptualize, this framework is biologically inaccurate. Human pigmentation exists across a broad, continuous spectrum. As human bands spread across the globe, localized microclimates produced unique selective pressures. Certain geographic regions featured intense solar exposure, others experienced moderate sunlight, and some endured drastic seasonal shifts. Furthermore, human populations continuously met and mixed over tens of thousands of years. The resulting evolutionary outcome was not three rigid colors, but thousands of subtle, overlapping shades forming an unbroken continuum across continents. Northern African complexions developed different pigmentation traits than Western African populations. Middle Eastern genetic profiles diverged from European patterns, while South Asian populations evolved traits distinct from East Asian groups. Indigenous Australians forged their own distinct lineage, while Native American populations inherited genetic traits from ancestral groups that traversed Asia long before written records existed. Humanity never split into neat categorical boxes. It diversified continuously and messily, precisely the way natural selection operates. Here is the profound biological truth underlying our shared history. If you trace any individual's family lineage far enough into the past, every human alive today shares the exact same African ancestral stock. Every single one of us. The person with the deepest skin tone, the individual with the fairest complexion, the Scandinavian athlete, the Nigerian engineer, the East Asian artist, and the South American farmer. Go back far enough and every branch of their family trees converges into the exact same trunk. This reality highlights something that society often struggles to fully grasp. The visible physical differences separating modern human populations are astonishingly recent developments. Our species spent far more time looking visually similar than looking distinct. The physical traits we emphasize today represent a tiny fraction of our species' total existence, a fleeting moment in evolutionary time. Beneath these superficial external variations, all humans remain astonishingly identical at the genetic level, far more homogeneous than most people realize. This realization brings us full circle to that solitary early human standing in East Africa 200,000 years ago. They had no concept of Europe, no knowledge of Asia, and no inkling that their descendants would one day erect modern skylines, construct complex networks, and debate one another online. They were simply focused on daily survival. Yet, contained within their biological lineage were the ancestors of every culture, every language, every physical feature, and every skin tone that would ever exist. The truly remarkable aspect of human pigmentation isn't that we look different. It is that our variations emerged in such remarkably predictable ways. A bit more solar exposure here, a bit less sunlight there. Thousands of years pass, genetic frequencies shift, and humanity gradually paints itself in diverse new complexions. We didn't split into separate species, nor did we sever our shared kinship. Our single species simply adapted to varied environments across the globe. So, what color were the first humans? They were undeniably dark-skinned, but that detail is merely the opening chapter of our story. Every skin tone visible across the globe today represents a chapter in the exact same evolutionary journey, a journey that began under the African sun, long before recorded history, long before national borders, and long before humans invented categories to divide themselves. The next time you look into a mirror, you are observing one localized variation of an evolutionary experiment that has been running for hundreds of thousands of years. And regardless of the specific shade looking back at you, the story originates in the exact same location. One single species, one shared origin, and one African beginning. Everything else was added along the way.